Are you looking for cloud network training? If so, this video is for you. We have an exciting announcement coming Monday, November 1st. So please make sure to subscribe to our YouTube channel and hit the bell. And follow us on LinkedIn to be notified of this special event. Hi, my name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects. And we're an organization that's dedicated towards building high-performance cloud computing and networking careers. Personally, I've been working in technology for over 25 years, and I've been mentoring others to get their first tech job or get promoted in tech for more than 2 decades. And my favorite thing in the world is when one of my students calls me and says, I just got cloud hired. Today we're going to talk about cloud network training. I consider this AWS networking tutorial to be very foundational cloud network training, but also very important. And these are critical skills for the cloud architect or the cloud engineer. So today we're going to talk about virtual LANs or VLANs. And a lot of times people will say, Mike, you're teaching VLANs, but this is cloud computing. And VLANs are critical knowledge for the cloud architect for the following reasons. Most of what we do as cloud architects are we take the systems in the network in the data center and we move them to the cloud, which is just another network in a data center that's just been virtualized. And because of that, we can't move systems that we don't understand. So the knowledge of the network is really critical. But when you connect to the AWS cloud, for example, over a direct connection, you have to send them a VLAN via a trunk or an 802.1q tag. So we're going to talk a lot about what that is. So the key is, even if it's network and data center technology, you can't get away with cloud computing without knowing about it. So this is very important foundational cloud network training. So now let's define, what is a VLAN? A VLAN, or a virtual LAN, is realistically speaking something we would call a broadcast domain. What is a broadcast domain? A broadcast domain is an environment where all your users can see each other's broadcasts. So computers themselves, they send out a lot of broadcasts. For example, when the computer boots up, they send out a broadcast message to get an IP address. That's an example when a computer wants to reach the router or reach something else, it sends something called an ARP, which is a broadcast. And we can talk about these other cool network things in another video. But the point is broadcasts are sent by systems to identify other systems and things. And a broadcast domain is when all the users can see each other. So if you've got one switch, by default, every user can see each other in that same switch. That is called a broadcast domain. Now, why would an organization use a virtual LAN? And why am I talking about broadcast domains? Here is the reason. Let's look in this graphic that you have here. Let's say I've got 2 sets of users or 2 broadcast domains, and I don't want the users to talk to each other. I have 2 options. Option 1, 2 physical switches. Plug my accounting users in one and my finance users in another switch. I don't make any cabling connections between the switches, and I have logical isolation, segregation, security. My accounting users can't talk to my finance users. And guess what? If I've got 2 switches, this is perfect. But what if I don't want to use 2 switches? What if I only need to use 5 users in one VLAN, for example? Do I want to waste the rest of the ports in the switch? Of course not. So virtualization came to the switches, and a VLAN or virtual LAN just enables us to chop a physical switch into multiple logical switches. So server virtualization enables us to take a server and chop it into logical servers. Virtualization and switching, or VLANs, enables us to take a switch and virtualize it into multiple switches. And VLANs have been around for at least 30 years. This is not new technology. So let's talk about it. If we've got 2 sets of users, we have the option to have 2 switches, or take 1 switch and create 2 VLANs. Now, how is this all gonna work? Let's say you've got a switch. The switch has 48 ports. You put ports 0 to 23 in one VLAN, and 24 to 47 in another VLAN. And guess what? Now, you've got 2 separate groupings of ports that are logically separated from each other. So that's how it works. So now, let's look in this picture here. In this picture, I've got 4 users. I've got 2 users that I want to talk to each other, and 2 users that I want to talk to each other, but I don't want the other groups talking to each other. So in this environment, I've created a VLAN 4. And in VLAN 4, I've got me, Mike, in there, and my COO, Chris, in there. And we can talk to each other, and we can share our secret information. Now, in VLAN 3, I've got my friend Jesse and my friend Praveen, and they can talk to each other. But note, Mike and Chris's data and Jesse's and Praveen's data is logically separated from each other. So we're in the same switch, but we're in two VLANs, and we're in two subnets. And we will not be able to talk to each other unless we get off of the switch through a router and get routed to each other. So we've got good protection, really good protection, all in the same switch. But what if we had multiple switches along the way? That's okay, we can extend our VLANs to multiple switches. So switching and virtualization really enables us to get greater utilization of our switches and much more flexibility and convenience. What's that sound like to you? Just like the cloud. All these things that you see in the cloud all came from the networking world. Virtualization of the LAN was one of the first virtualizations, and it's again 30 years old. So let's say we want to have two switches. Well, if we ran a cable if we had 50 users in one switch, 50 users in another switch, and we ran a cable between them, they could talk to each other. Well, guess what? If we had two accounting switches and two financing switches that were logically separate, we could run a cable between them and they'd be isolated. Or what if we had two switches that both had two VLANs? Now, if you look in this graphic, we have just that. We have a VLAN 30 and a VLAN 40. Note you'll see two switches. VLAN 30 is available on both switches, and VLAN 40 is available on both switches. How are we connecting VLANs 30 and VLANs 40? In this particular graphic, we have a cable from VLAN 30 to VLAN 30 and a cable from VLAN 40 to VLAN 40. Now, this works perfectly. This is basically multi-switch communication by putting a cable between both sets of VLANs. This will work perfectly. This is what you would do if you didn't have something called VLAN tagging. Now, in this perfect environment where we've got two switches and you can see two VLANs on each switch, we've got two sets of cables. And you know what? That might give us the fastest performance because it's directly a cable. But what if we only had one fiber optic connection between two buildings? Well, we only have one wire. What would we do? How could we use one wire to protect and logically isolate our stuff between two switches? Well, that's where we get involved in 802.1q tagging. So here's what happens. In this environment, as you can see on this graphic, we've got our layer 2 frame, which has got a destination address, meaning a MAC address, a source address being a MAC address, and this concept of a tag. So what we can actually do is we can take a VLAN and we can add its information via a tag. And what we can do is we can then create something called the trunk port, which I'll show you in a minute. And we can have one wire and have our VLAN traffic on that same wire, but separated from each other because of this 802.1q tag. So this 802.1q tag is magic at security and isolation, and now we'll walk you through it. But I just wanted you to know how we're going to do this with this 802.1q tag. So let's go back to this graphic here. If you look in this graphic, here's what you see. Two switches, VLANs 30 and VLANs 40 are both on these two switches. And we have a single cable between these two switches. That single cable is something called a trunk. Why is it called a trunk? Because we enable it to allow multiple VLANs on a single wire. Now look at that wire very carefully. Note the blue frame that you see that has 40 on it. That's coming from VLAN 40. And there's a pink one that says 30. And there's another blue one that says 40. And there's another pink one that says 30. We've got a single wire. And the traffic is being sent from the switches with the VLAN identifiers. That's how the traffic is kept separately. Now, how does this magic work? You've got switch 1. When switch 1 is going to take the traffic and put it on the trunk port, it adds the tags. So it's there for the wire. With switch 2, when it receives the tagged information, it says, okay, I got a tag. VLAN tag 30, let me remove the tag and send it to VLAN 30. I got a tag going to VLAN 40, let me remove the tag and send it to VLAN 40. So we've got perfectly separated information. to let you know, some service providers call this a VPN. This is a layer 2 VPN because we have virtual private communications across a single wire. So while it's not what you would typically hear of as a VPN, many service providers have offerings like this, and they're considered to be layer 2 VPNs. So now you know what's going on with the multi-switch VLAN trunking. So why are we talking about trunking? Let's recap it again. Trunking is used to connect a switch to switch. VLANs are used to logically isolate and virtualize a switch so you can create enhanced security by separating different groups of people on the same switch. Now, in between switches, you could run cables between broadcast domains or virtual LANs, or you could use a trunk port, which is a single cable or a group of single cables that are bundled together, where your traffic is logically isolated and separated by using an 802.1q tag. So there you have it. Now you know what is a virtual LAN, you know what a trunk is, and you know what an 802.1q tag is. This is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers. I hope you've enjoyed this cloud network video. This is foundational cloud computing training, foundational network training, and it is absolutely critical skills for the cloud architect or the cloud engineer. I look forward to seeing you in another video coming very soon. It was so nice having you join us for this video today. Let me tell you about some free services we do for the cloud community. Twice per week, we have a free How to Get Your First Cloud Architect Job webinar, where we tell you all the things you need to do and know to get your first cloud architect job. In addition to that, once per week, we actually have a free question and answer session live on YouTube, where you can come and ask us any questions you want about building your career related to cloud computing or networking, and we'll answer them in real time for you because we want to get you to your goals. Several more times per week, we have guests from industry experts that I've known for decades that are movers and shakers that have changed the world, that can give you information so you can build the best career. I invite them periodically. They are on my show. If there's a chance to do some free training on our channel, we'll do it live because we want you all to have the best skills for the best career. So please subscribe and hit the bell. I look forward to seeing you, and I look forward to assisting you in your technology career. Thank you so much. This is Michael Gibbs from Go Cloud Architects.